Pi there. So in this video, we will be dealing with systems of quadratic equations. So in dealing with systems of quadratic equations, the process is similar to linear equations. Our techniques will be the same, using elimination or substitution. So in this item, let us solve this by using elimination. To do that, we first set this first one as equation A and the second one as equation B. Now in applying elimination, what I would do is I would first eliminate this y variable. To do that one, observe that what we can do is we can multiply negative 2 to this first equation so that these two can cancel out. So we will have here negative 2 times A plus B. So multiplying negative 2 out here, we will have negative 4 times x squared plus 2x plus 2y equal to negative 8. For the equation B, we just copy it. Now that we have this, we can now add the two equations. Observe that if we add these two equations, negative 4 plus 3 would give us negative x squared plus 2x. Then here, 2y and minus 2y would cancel out. And then for the other side of the equation, we'll have negative 8 minus 7, which is equal to negative 15. Now let's simplify this one. So we can write this as the following. So first, note that we can move this expression to the other side to obtain 0 equal to x squared plus 2x minus 15. And then solving for this quadratic equation, it is easy to see that this quadratic expression here on the right factors out as x plus 5 times x minus 3. So clearly, to satisfy this equation, we have either x equal to negative 5 or x equal to 3. Now that we have the x values, what's only left is to find their corresponding y values using this or this equation. So to solve for that one, let us first remove this part of our solution. And let us solve for the corresponding y value. First, at x equal to negative 5, substituting this one to the first equation, we will have 2 times negative 5 squared plus 2 times negative 5 minus y equal to 4. Let us simplify this one. So first, we'll have negative 5 squared is just equal to 25 plus 2 times negative 5 will just be negative 10. So adding these two up will yield us 15. 2 times 15 is gonna be 30. This one will be 30. Then if you move 30 to the other side, we will have here negative y equal to 4 minus 30. This simplifies to negative 26. Multiply negative to both sides, and that will give us y equal to 26. This gives us the point negative 5, 26. Now we do the same for the other one. Let's first adjust this one. So next, at x equal to 3, using again the first equation, we will have 2 times 3 squared plus 2 times 3 minus y equal to 4. Let us simplify. 3 squared here is equal to 9. 2 times 3 here is equal to 6. Adding that up will give us 15. 2 times 15 is gonna be 30. So this one whole is 30. Move this to the other side. We'll obtain negative y equal to 4 minus 30. Again, this is equal to negative 26. Multiply negative 1 both sides. And that will give us y equal to 26. Or this represents the point 326. So this is the other point for this systems of quadratic equation. And these are our answers for this problem. So as you can see, the elimination process worked. The difference with systems of linear equations is that we obtained two solutions. So that is how to solve this problem. Let us move on to the next item. So for this one, since we have already used the elimination method, this time let us try using the substitution method. I prefer to use the substitution method since one of the variables is already written explicitly of the other. So like the first one, let us name these two equations. So by the substitution method, what we will do is let us substitute equation B into equation A. What will happen is we'll just replace all the y's here with x squared. So we will have 4 x squared minus x squared squared equal to 4. Then let us simplify this one. First, note that we can move this entire expression to the other side of the equation to obtain 0 equal to x squared squared minus 4x squared plus 4. Then what can you notice here? Notice that if we replace x squared here with just a, we'll have a squared minus 4a plus 4, which is essentially a perfect square. This means that we know how its factorization looked like. So this thing just factors into x squared minus 2 squared. And that is because the given is just a perfect square trinomial. Then take note that x squared minus 2 out here further factors into, so we'll have 0 equal to x minus square root of 2 and x plus square root of 2. So we'll have your square and square. So this time we use the difference of 2 squares. Now that we have this one, we now know the corresponding x values that would make this equation equal to 0. Clearly, these x values will be x equal to plus minus square root of 2. So that is the x value that we are looking for. Once that we have this, we simply substitute this x value into either of the equations out here. But clearly, it is easy to substitute it back to equation B, since in equation B, y is already isolated on one side. So notice that if we plug in either plus minus square root of 2 out here, what we will get is whatever y equal to plus minus square root of 2. If you square that one, that would always be 2, whether it's negative square root of 2 or positive square root of 2. So this means that in either cases, the solution set that we will obtain is first the point negative square root of 2, 2, and the other one is the point square root of 2, 2. This is the answer for this problem. So it's also quite straightforward. Again, same process as with linear equations, but we obtained again 2 solutions. Now, so far in our examples, everything seems to be going well. But as you recall, in systems of linear equation, there are cases that we might obtain no solutions or an empty set. We will illustrate this in the next example. In this example, again, we can either use elimination or substitution, but I would prefer to use substitution in this case because we have different powers here. In the first equation, we have squares. In the second one, we have linears or degree 1, which means that it would be hard to apply elimination out here. So let us use substitution. First, let us name these equations. So to apply substitution, we first note that in equation B, we can write one of the variables explicitly out of the other. So notice that since we have here 3y minus 2x equal to 6, if I move negative 2x to the other side, this will give us 3y equal to 2x plus 6. Then dividing 3 on both sides, this will give us y equal to 2x plus 6 all over 3. Now that we are able to do this, we can now substitute this value into the first equation. So we will replace the y out here with 2x plus 6 over 3. So substituting, we will have x squared plus 2x plus 6 all over 3 squared equal to 1. Let's just adjust this one. Then from here, let us simplify. So we will have x squared. Then for this other one, you can apply square of a binomial on the numerator to obtain the following expression. We will have 4x squared plus 24x plus 36. And in the denominator, we will have 9 equal to 1. Then just to simplify things, we can multiply 9 on both sides so that this denominator would disappear. So we will have here 9x squared plus 4x squared plus 24x plus 36 equal to 9. Then just to simplify this further, we combine these two terms with the same degree and then move 9 to the other side. This will give us 13x squared plus 24x plus 27 equal to 0. So we have here a quadratic equation. Before you try to factor out or solve this one, notice that if we check the discriminant of this one, so recall that for discriminant, if suppose we have a quadratic equation ax squared plus bx plus c equal to 0, then its discriminant is given by b squared minus 4ac. So solving for that one, so let's just put it here. We'll have here 24 squared minus 4 times e 13 times c. Note that we don't really need to simplify this. Just note that we have here 24 times 24. So we can write that as 24 times 24. Then we can multiply the 4 and 13 here. That would give us 52 times 27. Clearly, this one is smaller than this one. So subtracting the 2 would yield a negative value. This means that if we have a negative discriminant, we know that we won't obtain a real solution out here. So this means that for this problem, we have no solution. You can also write that one as a empty curly brackets or an empty set. So that is the answer for this problem. So as you can see, there are also cases that we don't obtain a solution. Graphically, this is how it looks. For this one, take note that that one is a unit circle, and then this one represents a line. So if it does not have a solution with this circle, the line may be around here, 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 or here, or wherever that is. Basically, the idea is just that it does not intersect any point in this circle. So that is the answer for this problem. As an exercise, you can try working on this one. This one is pretty simple. I suggest that you use the substitution method here, since on this second equation, you can easily divide 5 both sides to write y explicitly all in terms of x. So try this one, and also don't forget to check the description down below, as I have a Google form out there so that you can give your suggestions and ideas on how we can improve the content in this channel so that you can help me provide better math content that caters to your needs and wants. Yeah, so that's basically it. I hope you enjoyed this one, and have a nice day.